Okay, so here we are in 12.3. Today we will multiply polynomials just by monomials. A polynomial with a monomial. And remember, is a monomial a polynomial?
Yes.
It actually is. But is every polynomial a monomial? No. If it's a monomial, how many terms is in it? Yes, say it, Brandon. One term. There's one term, which could be a single number, a single letter, or a combination, a little product like you see here. This is 6D. That is a single term, 6D, right? And now we're going to multiply that to d squared minus 3d. So who can give us a strategy that might make it a little safer to do this multiplication right now? Tessa. We're going to use a distributive property, she says, but we might want to do one other thing to make it a little safer. Is that good? You might want to change this to adding the opposite so that we can really keep close track of these signs, right? And then as Tessa says, we'll distribute. So you can multiply unlike terms all day. You can, right? We have 6d times d squared. So how many d's will we have if we put this all together? 6d times d squared.
6d cubed.
Good. 6d to the third. Plus, we now have 6d times negative 3d. And so, let's show that. There it is. What is 6 times negative 3?
Negative 18.
Negative 18. And d times d is?
c squared.
C squared. There it is. So we have it written as an addition of terms. The second term is negative. So what could we do?
Subtract.
Subtract. We can say 6d cubed minus 18d squared. There is less writing, so that is simplest form.
Is that all?
Okay, that's it. This is getting trickier because there are more variables. So when you multiply d times d, you have to show that you have d squared, 2 factors of d. Otherwise, you've done a lot of this distributive property, haven't you? Okay, let's try it again. We have 3a to the 4th times 2a squared plus 9a cubed. Okay, so, right, when we do our first multiplication, 3a to the 4th times 2a squared. What is 3 times 2?
6
Good.
to the
6. I'm asking Ray. We have a to the 4th times a squared. So how many a factors will there be? We have 2 over here, and we have 4 over here. So in all, we have 6. A to the 6th. We add those exponents, don't we? Okay, because we wouldn't want to write out 6 times a times a times a times a times a times a. That would be just way too expanded. We can condense it with the exponent. And now we say 3a to the 4th times 9a to the 3rd. And that gives us, Bella?
27a.
A to the 7th. So who likes our expression? Who thinks we could even make it better? How could we make it just a little bit better? Who have I not heard from? Who else knows? Raise your hand if you haven't spoken. I want to hear from somebody new. Sarah. Put it in standard form. And what would that be? Excellent. And that's standard form because the first term has the higher degreed variable. The exponent is greater than this exponent of 6. Okay? And we're going to pause the video, try these, and come back and check your work. Good. And that was brought to you by Nico. And thumbs up if you agree. He says 2p squared plus 3p. Good job. Okay, and we're going to have the second one by Bella.
Does it not?
Because it never changes. So the 2 is always going to be 2. You can change the p to what you'd like it to be. Remember, you're gonna have to fit all of it in, so save a little room. And very good, excellent. Look, this X, she was just trying to be small. There's an X there. She was trying to save for him. And we could change where it says plus the negative 4x to the fourth to what, Bella? To minus 4x to the fourth. And otherwise we are good. Excellent. Okay, what about this? What makes this one challenging for students?
It's just backwards.
It's just backwards. You have this big factor, you know, this big thing, 3 parts, trinomial, is a factor being multiplied to this 5c cubed. So if you don't like to read, if you don't like this setup, what property could we use to get to our more familiar setup? Michael? Commutative, good. And so if we wanted to, we could take this factor and commute it over here if you prefer it on the left. Right? Do you have to do that? No. So let's just strain our brains a little bit and leave it on the right. We're so used to reading left to right that this makes us strain a little bit, which is good for our brains, right? So we can distribute this way. We can say 5c cubed times 4c to the fourth. What is 5 times 4?
20.
Everyone? 20. And c to the fourth times c to the third?
C to the 7.
7 factors of c. And then we can say 5c cubed times this, which is 1c squared. What is 5 times 1? 5. And c squared times c to the third?
C to the 5th.
c to the fifth. 5 factors. And then let's change this to adding the opposite. And we now have 5 times negative 2, which is?
Negative 10.
Good, negative 10. And c to the third. This 2 had no c. So there you go. You got it right. Did you leave it that way? Did anyone change it to moving the 5c over? And you still got the same expression, right? So if that's more comfortable, you may do that. That's fine. Okay, and your final practice? What's the number in front of x to the third? What's the coefficient that goes in front of this number here? Okay, so what is 1 times 3? 1 times 3. 3. And you wrote 4 by accident. Okay, so 4. 3 is the correct number. 3. 1 times 3 is 3. So you write 3, right? 3 x to the, wait a minute, how many x's are there out here? And how many here? Huh? And so together you have 4. Good. X to the fourth. And now the final one, x. Can you bring it down a little? I'm going to erase, bring it down lower. Your subtraction. Okay. X to the third times 4. Very good. Excellent. Okay. And this is the expression you should have. Okay. He didn't change the subtraction to adding the opposite, and he's still got the expression we need to have. Okay? So your assignment today, you have 20 minutes in class. You have 15 minutes, actually, which should be enough time for many of you to complete this assignment today. Have fun.